Hello everyone, welcome to my channel. So today we will discuss about another reaction, that is aldol condensation. Okay. Now which type of aldehydes and ketones normally undergo aldol condensation? The aldehydes or ketones having at least one alpha hydrogen atom undergoes aldol condensation, and this reaction occurs in presence of dilute alkalis like sodium hydroxide or potassium hydroxide or barium hydroxide. The final product formed is a beta hydroxyaldehyde if you take aldehyde, or a beta hydroxyketone if you will take the ketones, okay, respectively. Now let us take one example. Suppose last class we have already discussed about what is alpha hydrogen atom, what is alpha carbon atom, all this. Okay. Now acetaldehyde is an aldehyde having alpha hydrogen atom. Because this is your functional group, the carbon which is related to the functional group is your alpha carbon, so there is 3 alpha hydrogen atoms are there. So when 2 molecules of acetaldehyde or your ethanol treated with dilute sodium hydroxide, then it forms the final product, that is a beta hydroxybutyraldehyde. The beta hydroxybutyraldehyde means this is your functional group, this is alpha carbon, this is beta carbon, and at the beta position there is a hydroxy group attached. That is called beta hydroxy, and 1, 2, 3, 4 carbon atoms are there. So it is, the common name is beta hydroxybutyraldehyde. And if you do the IPEC name, it is 1, 2, 3, 4. So in 3 position there is a hydroxy group, so it is 3 hydroxybutanol. Okay, because in this product there are 2 functional groups, one is your alcohol, another is your aldehyde. That is why it is known as your aldehydes, say ALD plus alcohol से OL, ये मिल के आपका होता है aldol. Okay. Now another point is the aldol product, which is formed again, when you heat this product, then that means by dehydration, that means by removing one water molecule, it will form the final product, that is a alpha beta unsaturated aldehyde. See here, this is the aldol product. If you heat this, then there is a removal of water molecule takes place here. Removal of water molecules, that means this will go as H plus, this bond goes to this position, and here this is OH minus. Okay. So H plus and OH minus. So there is a removal of water occurs, and now there is a double bond here. So it becomes what? CH3CH double bond CH. In between these two there is a double bond, and C double bond OH. That means if this is your functional group, this one is your alpha carbon, this one is your beta carbon, then in between the alpha beta there is a double bond unsaturated. That is why it is called alpha beta unsaturated aldehyde. That is your alpha beta unsaturated aldehyde. Okay, and the common name of this aldehyde is your protonaldehyde. Very, very important, remember this. Now, and what is the IPEC name? 1, 2, 3, 4. Okay, so it is but is the word root. In 2 position there is a double bond, so 2En, and after aldehyde the suffix is Al, so it is but 2En Al. Okay, now let us discuss the mechanism. So first of all, what happens? The sodium hydroxide dissociates to forms Na plus OH minus. Okay. Now the step 1 is what happens? The base, that is the OH minus, first of all removes one proton from one molecule of aldehyde to form an enolate ion. So see here how it happens. This is your base OH minus. Okay. Now here one aldehyde molecule is there. Suppose if I will write the aldehyde like this, CH2H C double bond OH. This is one acetaldehyde molecule, right? So first what happens? This base, this abstract a proton. Okay. That is your alpha carbon. It abstract a proton. Take a proton. That is the nature, or take a alpha hydrogen. If this is alpha carbon, this is your alpha hydrogen. So it takes an alpha hydrogen. When it takes alpha hydrogen, this bond goes to this position, Now it forms what? This is the slow step of the reaction. Now it forms, this is your CH2 minus C double bond OH. Okay. Now there is a resonance stabilization takes place here. How it happens? See here. Now if this bond goes to this position, here this goes to this position, so there is a resonating structure possible, right? So it becomes CH2 double bond C single bond O minus double bond H. Okay. This is known as a resonance stabilized enolate ion. Okay, stabilized enolate ion plus H2 जो आपका बॉटल है. Now in the step 2 what happens? This is your step 2. Okay, so here the enolate ion will attach the carbonyl carbon of one aldehyde molecule. So see here, suppose this if I will write the aldehyde molecule, another molecule of acetaldehyde, that is CH3 C double bond OH. Okay, one molecule of acetaldehyde plus your enolate ion, that is CH2 minus C double bond OH. Okay, so here what happens? This enolate ion, this carbanion ion attacks the carbonyl carbon of another aldehyde molecule. This carbon becomes pentavalent, so the bond goes to this position. Okay. Now this is the reversible sign. Now what will be the product? The product will be, see here, this is your CH3 C H CH2 C double bond H and आपका यहाँ पे क्या होगा? सिंगल बॉन्ड O माइनस. Okay, so this is the formation of an anion. This is suppose your structure number 1. Okay, now what happens in the step 3? What happens in the step 3? So in the step 3 what happens? Again the anion which is formed, that takes away one proton from the water molecule. Okay, so see here, this one is your structure number 1, C O minus H. This is your CH2 C double bond H plus one water molecule. If I write water molecule like this, HOH. So here what happens? This becomes H plus. Okay, and this removes its OH minus. So what will be the product? This becomes the CH. Final product is CH3 C single bond OH H single bond CH2 single bond C double bond H. So this is your aldol product. Okay, this is your aldol product. This is all about the mechanism. Now, how will you know the product without doing the mechanism? See here, suppose if you will write only the product, okay, for 1 mark question. See here, suppose 2 aldehyde molecules are there, acetaldehyde molecules are there. See here, if I will write CH3, okay, C your double bond O H here. Another molecule of CH2, if I will write that in H CH2, okay, C double bond O H. So here what happens, you just take one hydrogen here and attach to this position. Now this double bond is converted into a single bond because one hydrogen is attached here. Okay, and to this carbon will be attached. So what will be your product? CH3 CH single bond OH. Okay, now already the hydrogen is there, so it is CH2 C double bond OH. this is your aldol product. Okay, this is aldol product. See here. Now this is only for remembrance. Okay, this is not the mechanism. Only just only a trick to know the product without doing the mechanism. Okay. In this way, you can also write the alpha beta unsaturated aldehyde product. That means on dehydration, how you get the product. See here, in between the first the alpha carbon and beta carbon. Always remove one water molecule from the alpha and beta position. So how will you remove that? Suppose if I'll write, see here, if I'll write the hydrogen, here CH2 is there, so if I'll write, this becomes HH. Okay, now this goes HH plus, this bond goes to this position and this becomes this. So what will be the product? 115, one water molecule will be removed, so product becomes CH3 CH double bond CH C double bond H. Okay, see here, this is your alpha carbon, this is your beta carbon, so it is your alpha beta unsaturated aldehyde, that is your product. See here, this is your alpha beta unsaturated aldehyde, that is your protonaldehyde. Okay, so in this way, can you tell me other examples? Okay, see here, suppose, see, this one is your propionaldehyde. Okay, this is another propionaldehyde. And another thing, remember the condensation, self-condensation. When there is a self-condensation occurs between the same molecules of aldehyde or same molecule of ketone, then that reaction is known as simple aldol condensation reaction. So here the examples which we are discussing, they are examples of simple aldol condensation reaction. Okay. Okay. Now see here, this is the propionaldehyde. Now similarly we will discuss some other examples. Suppose take propionaldehyde. Okay, this is another molecule of propionaldehyde. So tell me what will be the aldol product. See here, when this one is your functional group and this is your alpha carbon. Okay, so always remember one thing, the alpha hydrogen, if this is alpha carbon, this is your alpha hydrogen, the alpha hydrogen will attach to the carbonyl carbon, that means the oxygen of carbonyl carbon of the another aldehyde molecule, and this carbon will attach to this carbon and you will get the aldol product. See here, CH3 CH2 C, hydrogen is attached to this position, OH. Now again this carbon will attach to this position. See here, this carbon is attached. Now CH3, here in the down there is CH3 CH. So this is your aldol product. The same way. Similarly, again when you heat it, it will undergo dehydration. Dehydration from which position? This is your alpha position, this is your beta. So one water will be removed from this here, then you will get a double bond here. Okay, now see here, this hydrogen is your what? Alpha hydrogen. This one is your alpha hydrogen. Okay, now one hydrogen will go to this position and there is a double bond occurs, again OH minus is removed. So all totally water molecule will be removed and here there will be a double bond. So the compound is like this, CH3 CH2 CH double bond CCH3 C double bond OH. Okay, this is your alpha beta unsaturated aldehyde. These are the IPEC names you will do. Similarly, see here another example, when you will take two acetone molecules. Now see here, if this one is your functional group, these are two alpha carbons, means there are 3 alpha hydrogen here, 3 alpha hydrogen here. You can take one alpha hydrogen and attach to this position and it becomes CH3 CCH3 C single bond OH. And now here only CH2 is there, this will be attached to this position, CH2. Okay, already shown here, that becomes CH2 C double bond or CH3. Okay, again if we will heat it, then there is a water molecule is removed from these positions, alpha and beta position, and there is a double bond occurs here, so it becomes CCH3 double bond CH3. Okay, this is the final product. all are in the same manner. Okay, and another important point is, remember this compound, common name of this compound is 𝗔𝗹𝗱𝗀𝗀. Okay, always in एग्जाम में आपका क्वेश्चन ऐसे भी आता है, राइट द स्ट्रक्चर ऑफ 𝗔𝗹𝗚, राइट द स्ट्रक्चर ऑफ प्रोटोनाल्डिहाइड. Okay, so you have to remember this common name of this compound is 𝗔𝗹𝗚𝗀𝗀. Okay, thank you. Now next we will discuss cross-aldol condensation. So what is cross-aldol condensation? This is the condensation reaction which occurs between two different aldehydes or two different ketones, or between one aldehyde and one ketone in presence of a base. Now suppose we will take two different aldehyde. One is acetaldehyde and another one is propionaldehyde. Okay, one is acetaldehyde and this propionaldehyde. Now when there is a reaction occurs between two different aldehyde, actually there is four products will be formed. How? Now there is a self-condensation reaction takes place between the two different aldehydes, and another two products is the attachment of one aldehyde with another by the enolate ion. Okay, see here. Now how will you remember this product? First of all, you know that when acetaldehyde reacts with acetaldehyde, when acetaldehyde reacts with itself, acetaldehyde, what will be the product? You have to write the aldol product, that is CH3CHOH. That means one alpha hydrogen will attach to this position and this will attach to this carbon. So if I write the first product, acetaldehyde with acetaldehyde, the first product will be CH3. Okay, then again one alpha hydrogen from another aldehyde, acetaldehyde will react with this. So compound will be what? This compound will be CH3. This one, CH3CHOH, CH2CHO. So CH3CHOH, CH2CHO. Okay. Second is when again propionaldehyde attached with itself, self-condensation takes place. What happens here? We know that always the hydrogen, which type of hydrogen? Alpha hydrogen will attach to this position. So here, see here, if I will write propionaldehyde CH3 CH2 C double bond OH plus another molecule of propionaldehyde. See here, CH3 CH C double bond OH. Here, if this one is a functional group, this one is alpha carbon. So in between this, in the reaction, when this occurs, the hydrogen which attached to alpha carbon, that is alpha hydrogen, will go to this position. Okay, so what will be your product? CH3 CH2 single bond COH, here it is H, and here this carbon will attach to this position. Okay, and it becomes CH. Here the CS which is attached, you can write this CS3 and this is C double bond OH. Okay, so this is your when propionaldehyde reacts with itself. See the product, see the product, see the product. This CH3 CH3 CH2 CHOH CH3 CH. Second product. Okay, so this is the first product, self condensation of acetaldehyde. This is self-condensation of propionaldehyde. Now the next product is between acetaldehyde and propionaldehyde. One will form the enolate ion and it will attack the carbonyl carbon of another aldehyde molecule. Now see here, first of all, when propionaldehyde form the enolate ion and it will attack the acetaldehyde molecule, what will be the third product? The third product becomes, see here, the third product is, if I will write CH3 C double bond OH, here it is your what? CH3 CH2, this is CH2 CH. So this is your alpha carbon, this is alpha hydrogen, this will goes to this position. So what will be the product? CH3 CH OH CH single bond CH3 CH. Now see the third product, when this compound from the enolate ion and it will attack the acetaldehyde, that is the propionaldehyde. So third product is your what? C is the third product, CH3CHOH. The fourth one is here the acetaldehyde molecule from the enolate and it will attack the propionaldehyde. So see here, if I'll write the propionaldehyde like this, CH3CH2 C double bond OH, and here CH3CHO aldehyde is there. Now it will form the enolate and it will attack to this. So this is your alpha carbon, one alpha hydrogen from here. If I'll write this is CH2H, then this hydrogen will go to this position. So what will be the product? This is your CH3CH2 single bond C OH CH, and this is attached to CH2 CH. See here, this is. Now tell me what will be the product. Okay, now if this one is your functional group, this is your alpha carbon. Okay, so if I'll write the product, see here, see here, one hydrogen from here will attach to this position, so it becomes COH. Okay, if I'll write the CH3 here, then this carbon will attach to this position. Okay, so here it is CH2 C double bond O. Okay, so this is your A product. Now when you heat this, then there is a dehydration takes place. Now dehydration takes place means here what happens again, this one is your functional group, this is your alpha carbon, this is your beta carbon, one water will be removed here, hydrogen, and this HOH. So here there will be a double bond. So what will be the B product? What will be the product? It becomes C single bond CH3 double bond CH double bond. Okay, so this is your P product. Now an important point is always remember formaldehyde, benzaldehyde and benzophenol. These are the compounds which do not undergo simple aldol condensation. Because why they will not go simple aldol condensation? Because due to the absence of alpha hydrogen atom. Simple aldol condensation is the condensation between the same type of aldehyde or same type of ketone. Okay, so these compounds do not undergo simple aldol condensation reaction. Okay. Thank you. Now another point, remember, important point, cross aldol condensation can also be possible between two aldehydes or one aldehyde and one ketone. But in between these compounds, one should always contain one alpha hydrogen atom and the other one having no alpha hydrogen atom. That means the aldehydes having no alpha hydrogen atom cannot undergo self condensation but can undergo क्रॉस aldol condensation. वो self condensation नहीं हो सकता but वो क्रॉस aldol condensation दे सकता है. Okay, so suppose see here, this is the example. If I write formaldehyde having no alpha hydrogen atom, when formaldehyde reacts with acetaldehyde, where there is a alpha hydrogen atom because it is alpha carbon, alpha hydrogen. So this is one example of aldehyde having alpha hydrogen atom. This is an example of aldehyde having no alpha hydrogen atom. When treated with dilute alkali, then also they will form the product. How it forms the product? See here, how the product will be formed. Always here what happens, remember, here what happens, always the aldehyde having alpha hydrogen atom will form the enolate ion and it will attack the carbonyl carbon of another aldehyde molecule. That means if I will write the compound, suppose HC double bond OH. Okay, so here what happens, the acetaldehyde having alpha hydrogen atom that will form the enolate ion. That means that compound will attack the carbonyl upon the fixed aldehyde molecule. Okay. Due to this, what will be the product form? The product will be a what? This is the mechanism actually. If this will be the mechanism, then what happens? We know the short trick. How will you remember the compound? This becomes your what? CH2. If I write the compound CH2, then single bond, it becomes your what? C single bond OH. It becomes, this hydrogen will go to this position, so it becomes CH2. This becomes CH2. Okay. Now to this oxygen, one hydrogen will go to this position, so it becomes OH. Okay. Now next is, to this carbon already the CH2 will attach, so it is will attach to CH2. So this will be the product. See here, CH2OH, CH2CH2. Similarly, see here. Similarly, when formaldehyde, we know alpha hydrogen atom, attached to, reacts with acetone and in presence of dilute alkali, what happens here also? This one is a functional group. This is one alpha carbon. This is one alpha carbon. That means 3 alpha hydrogens this side, 3 alpha hydrogen this side. So one of the alpha hydrogen atom will go to this position. The product will be CH2 single bond OH, CH2 single bond OH, and here the CH2 COCH3 will attach to the carbon. It becomes CH2 COCH3. This will be their product. Okay. You can do the name of this compound of your own. Okay. Thank you.